Okay, and here's like the second part, I guess, of the video, but like, it's just that I didn't want to like, do the mechanical and the, was it, like, basically, yeah, here's the next question, basically. Hello, everyone. So, first of all, let's calculate, so please read the question, blah, 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 boom, 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 A. So A is asking to calculate the time taken for the engine to travel 200 meters. Over here we can literally see that it goes 4 meters one each second. So what we do is we just divide 200, how much we need, by 4, because that's how much it's going at, and that gives 50. So 50 seconds. Yep. So now this is A. After that, B. Basically, B is much more hard. Basically, the formula wasn't even the formula. The formula was not even in the formula sheet, like in my booklet. However, the formula to answer this question is basically that what is it? Yeah, M1, initial velocity 1, and what was it? I'm pretty sure plus M2 times U2 equals M1 velocity 1 plus 2 V2. I'm pretty sure. It was something like the something M velocity or some whatever it is. And right now I'm just trying to figure out if that's the right thing. Well, basically, yeah, it should be the right thing. So basically, look. It says that the engine collides with the stationary. So this initial velocity is 0 straight away. The mass is 5,000. Over here it's 50,000. Over here the initial was 4 meters, because right after the collision it's not 4, so it was 4. So this is equal to this. So, and also since it was what's it called, it didn't move. So so like look, basically it's not moving. This one is moving, it pushes it. After they push, they move at the same time. So that means that acceleration and velocity are the same, so that's much more easier. So after that, basically, look, just straight to the point. 4 times 50k, 200. 5k times, let's just do it that way. 5k times 0 is 0, so this is equal to 200k. So after that, since the velocity is the same, we're able to say that the 200k equals the mass plus the mass 2 and the velocity, and I'm pretty sure, yeah, it's times. So this equals 55. Take away 200 is 145 equals to V. But that's not it, because where did I write that? Oh no, we divide it. Yeah, we divide it by 55. We divide it by 55 because over here there's a times over here. So, and the answer is 3.69 newtons to the first, like to the place or whatever. So yeah, that's it. So that's it. And then there's another one. this one. Let's go. Please read the question. Okay, let's go. So look, that it accelerates for 8 seconds and it's at constant velocity 3 meters each second squared. So yeah, that's a squared. However, strange that's not on the top like here. So I'm just thinking, well, it can't be 2 seconds because it would be written like this. So it's second squared. They just made this bad, like they're trying to trick us. So how to find the velocity is going to be 3 times 8. You might think, wait, but it's squared. It doesn't matter. It's all this, basically, yeah. It does matter, but at the same time, yeah, this is the answer. Meters a second. And I'm thinking, is there a way to check it? Well, no, not really. Okay, and then read this part, please. Okay, basically after here it starts decelerating, and we have to find out, calculate like the distance traveled by the car while it's accelerating. Distance in equations is given by c, like seconds, but yeah, basically yeah. So, and in the thingy, like equation that I used, there was an equation, the formula sheet that says v2 equals initial velocity plus 2ac. So, why do I say I when it was my teacher helping me? But either way, we make as the subject, which we make it by, first of all, moving it here. So we have, no, actually, let me think. Yeah, we move it here, so we get v2 take away 2ac equals initial velocity 2. Then we get the thingy v2 here plus v2. Then we get rid of the, what's it called, 2a, and we move it here, so plus 2a. And I'm not really sure if it would stay as a negative. However, my teacher, let me see in the picture. I have a picture of the thing. Dum 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 boom boom. Yeah, no, it was not. And also I did it wrong. It's not like this. Because it was here, it was times in the s, so it's dividing 2a. And yeah, the a stays. It doesn't stay, it's positive basically. So let's substitute the numbers. So the initial velocity is 3 squared plus 4 squared times the, oh wait, let me think, wait, what? Oh wait, I did it wrong. Basically, this is the initial velocity, right? Yeah. So initial. Okay, basically, the velocity is now 0 because it's at rest, right? it says that's the rates at the traffic. So our take away the initial was 24, dividing by 2, and the acceleration is -4 since it's accelerating instead, and the answer base is 72. So yeah, thanks, goodbye.